Hi, this is Ms. Jones, and this video is to walk you through a little bit about the metric system and then how we're going to be using unit conversion in this course. So first, we'll look at the standard units that we use for each type of measurements, and you're going to be copying this table into your notes, and so I'll show you guys that. The first thing is length. We use the meter, and the abbreviation is M. And so if you count the rows that are in here, we've got the header row up here, and then we've got 1, 2, 3, 4, 5, 6. And so we only need 6 rows here in our notes, and so I'm going to count down. This I can use for the header. And we're going to use 6. Now, these words aren't that wide, so I don't actually need to use the entire width of my page, and your notebook might be even bigger, so you probably don't need it. So what I'm going to do is I'm going to start typing the header up here. Physical quantity, and that's the widest that needs to be. The metric unit, that's the widest that needs to be, and I'm going to actually abbreviate the word abbreviation. And so it looks like I am using most of it, but yours might be larger. And so there we go. And we're using 5 different types of physical quantities. So 1, 2, 3, 4, 5. I'm just going to make a table. If you like your tables to be straight, you can use a ruler. And there we go. Also, I almost forgot, but don't forget you need to title your notes. So a good title for these notes would be the title of these, so unit conversion and the metric system. Alright, so let's go ahead and fill these in. We always start off with the base unit of the meters for length, meters, and lowercase m is the abbreviation. For mass, we use the kilogram, and that's lowercase k, lowercase g. For volume, we use the liter, and that is a capital L. For temperature, we use either Kelvin or Celsius. I always spell Celsius wrong, so I've always got to double check. And Kelvin is a big K, Celsius is a big C. And for time, our base unit is the second. And that is lowercase s, although sometimes I will write it as SEC if I'm worried that it might get confused with something else. Now I wanted to point out this one up here is already 2 pieces. It's kilo and gram. Gram is the base unit, but we commonly use kilograms whenever we're measuring mass, and so even though gram is the base unit, and that's G, kilogram is considered the basic metric unit of mass. Alright, so having that copied down is going to be helpful for the future. Let's take a look at this. So whenever you're measuring something that's really large or really small, you have to use prefixes to say just how much larger or smaller. So this dash down right in the middle that corresponds with 1, that's the base unit. That's the meter, the liter, the gram, the second. And then if you go smaller than 1, you're going towards deci and centi and milli. And when you're going larger than 1, you're going towards deca and hecto and kilo. And so this actually goes, they have words for almost everything. You've probably heard of a nanometer. You've probably heard of a micrometer or we use millimeters all the time. But it's possible that you've seen some of these before. these are the ones that we use the most, going from kilo to hecto to deca to the base unit to deci to centi to milli. Especially in regular high school science classes, these are usually the ones that we stick with. So what you're going to do is you need to be able to memorize the order that those go. And so we usually go from the larger one, kilo, down to the smaller one, milli. And here's an example that I was given by a student my first year of teaching. They had heard it from their junior high teacher. King Henry died by drinking chocolate milk. And that's just a mnemonic for remembering the order. So King stands for kilo, Henry stands for hecto, died stands for deca, by is the base unit, whatever you're basing this off of, drinking stands for deci, chocolate stands for centi, and milk stands for milli. And so you're going to want to memorize K, H, D, A, D, C, or something, and then D, C, and M. You're going to want to memorize the order of that. So you are actually going to come up with your own in a bit. But first, let's go ahead and copy this conversion chart into the notes. It's really useful to see, especially with this staircase pattern, that you're going from something that's a larger number down to something that's a smaller. And it gives us this handy conversion tool as well. If you have a printer at home, you can always print off this slide and cut this out and tape it in. But I'm going to show you guys me just going through and drawing it myself. So if you see this here, we've got 7 different steps. We've got kilo, hecto, deca, base unit, deci, centi, milli. And so I'm going to reserve 7 rows for this. So I've got 1, 2, 3, 4, 5, 6, 7. I'm going to go ahead and box that off so that I can use this whole piece of my notebook to build this, because this metric conversion chart is super useful. So I'm going to title it Metric Conversion. And we're starting with kilo over here, hecto, deca, base, deci, centi, milli. And I'm going to draw that staircase like this. And I think the numbers are also super useful. So the base unit represents the number 1. Deca represents 10, so like times 10. Hecto represents times 100. Kilo represents times 1,000. Deci is 0.1, also known as divided by 10. Centi is 0.01, which is divided by 100. And milli is, I know I didn't leave a lot of room for this, but 0.001, which is divided by 1,000. And so here we can do this little handy tip to convert to a larger unit. Converting to larger, move decimal point to the left. Move decimal, I'm going to do left in big letters, and I'm going to say divide, because that's what it says too. And then here, let's make a nice big box. Converting to smaller units, move decimal, right, and let's go ahead and draw that one, and multiply. Alright, so that's my version of that same chart that you guys have in your notes. So the next thing that you're going to do is you're going to come up with your own mnemonic for remembering the order of the prefixes. So these are just a couple varieties of the same one. King Henry died by drinking chocolate milk, where by represents base unit. There's also King Henry died unusually drinking chocolate milk, where U just stands for unit. And so what you're going to do, there's also, oh yes, and there's also King Henry died while drinking chocolate milk, while W just kind of stands for a generic, standard, whatever. So what you're going to do in your notes is go ahead and write out the order of those letters. So we've got K, H, D, and then something. And so that so far is usually King Henry died, or kilo hecto deca, that you're going to decide what that K, H, and D stand for. The something, you can use almost any letter as long as you remember that that middle letter has to do with just the base unit. So let's continue on. We've got King Henry died something drinking chocolate milk. That's how I remember it. But how are you going to remember it? You're coming up with your mnemonic for remembering the order of the prefixes. Try to make it something fun. Remember, you can use any letter you want for the middle one. So I've had examples of kangaroos hate dogs, and then something about donkeys and scents and milk. There's lots of different words that you can use. Try to make a sentence that kind of makes sense that you can memorize. All right, so this is for you guys. You're going to come up with something to remember this. And I would like to see it written out here. So for example, kitties hate doggies. And let's go with because dogs create mischief. That's one. So don't use mine, but come up with something similar, all right? Something where you can memorize the order, and so you can draw this staircase even if you don't have your notes. Let's go ahead. That's it for the metric system part of our notes. So look at your page, see how much room you have left. So for example, I only have this little part left here, and I'm probably going to use at least a full page for the unit conversion part of my notes. And so I'm actually going to leave this part blank for now because I would like to actually draw a little doodle of kitties hating dogs because dogs hate or dogs create mischief or something like that. Just because I like to add doodles to my notes. Another thing that you can do is also highlight different words and the headers and the individual prefixes here just to make it stand out, to make this look different from your other notes. So for example, here's my scientific notation notes, and I've highlighted different things to make them stand out. And so I'd like to do the same thing here. So I'm going to go ahead and do that and show you what mine looks like. So here's what my notes look like after I've spent a little bit of time. I've colored some of the headers, I've darkened some of the notes, and it just kind of makes it stand out. And I went ahead and I drew my little doodle of cats hating doggies because doggies create mischief. So you can add doodles to your notes whenever you'd like, especially if it helps you remember things. And I highly recommend highlighters or colored pencils to just sort of brighten your notes up and make them a little bit more interesting than just an entire page full of writing. So let's go ahead and move on to the next part of the notes. Unit conversion. So any measured quantity, so anytime we use numbers in science, consists of two things, a number and a unit. I know some of you have had teachers who in the past would be like, why is your number naked? Because it doesn't have units and that sort of thing, and that's true. Most numbers in science have a unit attached to them. If I say, how old are you? And you say 13, I'll be like, wow, you're only 13 months old? That's incredible. And you'd be like, no, I'm 13 years. Well, why didn't you say so? I know sometimes it's implied, but with science you need to make sure you're very specific. If, let's say, you did know your age in years, but you needed to find it out in months, we can actually use unit conversion to change from one unit to another. And so what we're going to do first is we're going to title our next page of notes if you haven't already. And whenever you're continuing notes, you just kind of say the same title as before but continued. That way every page has a title and you can tell which notes they are. So up at the top of my new set of notes, this is unit conversion. Continued. All right. So the very, very first thing that we're going to be doing is basically defining unit conversion, or defining conversion factor. That is the very first thing we're going to do. So conversion factor. And so I'm going to have a little definition for this. I'm going to make this one cute afterwards. So I'm not going to bother with the highlighting or the drawing stuff around it until after I've got the language down. So let's take a look. A conversion factor is a fraction or ratio that is equal to 1 that helps us change units. So a fraction or ratio that is equal to 1, and it helps you change units. This is for change units. Let's do an example. So an example of a conversion factor would be 1 centimeter is the same as 10 millimeters. That's a conversion factor. I could also write the same thing as 1 centimeter as a ratio to 10 millimeters. They mean the same thing. 1 centimeter and 10 millimeters means the same thing, so technically, if you did divide those, it would equal 1. But we can use this fraction here to convert whenever we need to. Alright, so let's look at this. Here's some more example conversion factors. So if you know that there are 60 seconds in a minute, then you could say the ratio of 60 seconds to 1 minute. Or you can use the conversion factors 60 seconds per minute or a minute per 60 seconds. And so either one of these would count as a conversion factor. And you can say 60 seconds per minute with 60 on top, or you can say 1 minute per 60 seconds with 60 on the bottom. Since they are equal, you can have either one on the top or the bottom, and you're going to find out why that's useful in a minute. Other examples, there are 1,000 grams in a kilogram. That's what the word kilo means. So if you have 1 gram 1,000 times, then you have a kilogram. There are 100 centimeters in a meter. There are 1,000 milliliters in a liter. And there are 12 months in a year. You could also say 1 year over 12 months. All of these can be flipped upside down if you need to. So when you use the conversion factor, you need to find out what your new units are going to be, and you need to identify what your old units are in order to be able to choose your conversion factor. So here's an example. How many minutes are in 367 seconds? Well, first you need to identify what were your new units. What are you being asked for? So it's asking how many minutes. So your new unit needs to be minutes. Your old unit is what you're given that already has the number attached to it. So 367 seconds. Your old unit was seconds. And so now you need to find which conversion factor has the new units on top and the old units on bottom. And you'll see that it helps it cancel out the old units when you put them on the bottom. Let's go ahead and write that in our notes so that we can keep them. So I'm going to separate out. Let me show you what I'm doing with my notes right now. I'm going to separate this. That's my nice little definition of what conversion factor is, and I can highlight that later. But right now, using the conversion factors, in order to get the new units, that's going to be the old units times the conversion factor. And you choose the conversion factor that has the new units over the old units. So choose the conversion factor with new unit, so what you're looking for, divided by old unit, what you're trying to cancel out. Alright, I'm just going to make that nice and zigzag. Maybe I'll highlight it yellow so it really stands out for later. So let's look at this example. How many minutes are in 367 seconds? So the first thing is you identify the fact that the old unit, the one that you were given, the old unit is the one that has the numbers attached to it. So here, minutes doesn't have any number attached to it, but seconds does. And so you can tell this is the unit that you were given, it's old, and you need to convert it to new one, minutes, which is what you're asking for in this question. So the old unit, 367, times some sort of conversion factor is going to give us how many minutes, which is the new unit. So we need to choose a conversion factor. So minutes to seconds is 60 seconds to minute, or 1 minute per 60 seconds. These are the exact same. But why are we choosing this one instead of this one? It's because if we put seconds on the bottom, then they will cancel out. So if we have 367 seconds times 1 minute per 60 seconds, this second is on top of a fraction, while this second is on the bottom of a fraction. The seconds cancel out, and minutes ends up on the top. And since it's asking how many minutes, you want your answer to be in minutes. And so having the seconds cancel out is what you need when you're choosing your conversion factor. So make sure that the units you're trying to get rid of are on the bottom. Now for our notes, we should have at least 2 example problems walked through. So I'm going to go ahead and set up 1/2 of these pages for 2 different example problems. So I'm going to write example problems. And it gives me plenty of room for writing down what I'm doing. So go ahead and take a look. This is what my notes look like right now. I'm setting up the rest. You see the stuff I used on the other page bled through, so maybe I'll reserve this part down here for some sort of doodle to cover that up. But up here I've got plenty of room to write out the example problems. So how many years would it take for mid-ocean ridge that is spreading 4.2 millimeters per month to spread apart 12 kilometers? So first, we need to figure out what the speed is in kilometers per year. That's what the question is asking. So how many years would it take to spread apart a certain number of kilometers? So we have to convert millimeters per month into kilometers per year. That's 2 conversions. We need to convert millimeters to kilometers, and we need to convert months to years. So here we've got kilometers, and years is what we're going for. We're trying to get rid of millimeters and months. So for distance, there are 10 millimeters in a centimeter, there's 100 centimeters in a meter, there's 1,000 meters in a kilometer. And so you could also memorize, or you could just do this step by step, or even look it up. There are 1 million millimeters in 1 kilometer. So our conversion factor is 1 kilometer per 1 million millimeters. Remember, the one that we're getting rid of, the one that already has the number attached and we need to cancel out, that millimeters needs to be on the bottom because it's on the top up here. It needs to be on the bottom in our conversion factor. So let's go ahead and write that down. So how many years to spread 12 kilometers if it moves 4.2 millimeters a month? So I'll show you guys what I've written down there. You notice I don't have to write down the entire sentence. I'm just putting enough where I kind of know what the setup is. I need to know how many years it would spread 12 kilometers if it's moving 4.2 millimeters per month. So, keeping that in mind, we are going to be using the conversion factor of 1 kilometer per 1 million millimeters. So we've got 4.2 millimeters, and I like to draw my fractions like this when I'm using the math so that it's easier to tell when they cancel each other out. So 1 month, and then we're going to multiply this by the conversion factor, which is 1 kilometer per million. Remember, that's 6 zeros, millimeters. The millimeters cancel out, and then let's figure out how to get rid of this month. So, the conversion factor for time, there's 12 months in a year. Alright, so 1 year equals 12 months. Why, if I'm saying we need to cancel out months, why would I put months on top of this fraction? Can you spot why? It's because month is on bottom in the number we're trying to cancel out. So months is already on the bottom of this fraction, so in order to get that to cancel out, our conversion factor needs to have months on the top. So, let's go ahead and add that one, multiply I mean, add that to this series of problems is what I meant. So 12 months per 1 year. Okay, so now we can cancel out month, and we can see that our answer, all of the units are gone except for kilometers per year. So we're going to get the speed of this in kilometers per year if we put in these numbers. So 4.2 times 1 we can ignore, but times 12. Those are the numbers that are on top. At the bottom we've got 1 which we can ignore, 1 million. And then 1 which we can ignore. And then the units, kilometers per year. So this would just be plugged into a calculator to find out how fast this thing is moving in kilometers per year. If you plug this into the calculator, you'll find that your answer ends up being a bunch of zeros after the decimal point. 1, 2, 3, 4, and then 504 kilometers per year. So now that's really slow, but this number can help us find out just how many years it would take for it to spread 12 kilometers. So here we've got how fast it moves in kilometers per year. And I got that from putting it into a calculator, although you could also look at the way that I've done where I kind of separated it step by step. If you multiply all the top numbers, you get 50.4. The bottom number is just a million, and so you take 50.4 and move the decimal place 1, 2, 3, 4, 5, 6 times to the left. And so if you see, this was 50.4. If the decimal place is right here, and I move it 6 times to the left, you'll see that it would be 4 zeros and, or wait, I'm waiting for it to go away. 4 zeros, and then the 5, and then the 0 and the 4. So that's how you could do it in your head if you really wanted to, but I would still have to put it into calculator to get the 50.4. So writing that in scientific notation would be 5.04 times 10 to the negative 5. And so I'm going to go ahead and write that one down. 5.04 times 10 to the negative 5 kilometers per year. And the negative 5 shows you that this is a number much smaller than 1. So, we know the speed. So let's find out how many years it would take. We have, this is now our conversion factor. We just created a new conversion factor. Most speeds count as types of conversion factor. We know that we want to go from 12 kilometers, and we want our answer to be in year. And we've created a conversion factor that tells us how many kilometers are in a year. So, if our new units need to be in years, and our old units are in kilometers, we need kilometers to be on the bottom. And you can do this just fine, because these are equal to each other. For every year, there's this many kilometers. We can flip this over. The conversion factor needs the new units on top. And so we're going to take how long 12 kilometers would be, and we're going to multiply it by this conversion factor, but flipped upside down. So it's going to have year on the top, because that's what we want our answer to be, and it's going to have the 5.04 times 10 to the negative 5 kilometers on the bottom. Okay. One thing that we've learned in the past is this negative exponent. If you have a negative exponent on the bottom, you can actually bump that number up physically to the top, because what this is basically saying is this is the inverse of times 10 to the 5, and it's already on the bottom. So if you see a negative exponent, you can move that number up to the top and take away the negative. The kilometers will cancel out, and you're going to end up with 12 times 5.04 times 10 to the positive 5, because we moved it up to the top, and that will be in years. So if we plug this into a calculator, we would get about 6,048,000 years. So 6,048,000 years, that's over 6 million years is how long it would take for that mid-ocean ridge to spread apart 12 kilometers. So I'm going to go ahead and highlight my answer. Always put a box around and highlight your final answer. I'm going to use a different, slightly dimmer highlighter to highlight my halfway there answer, which was my speed. So this was the conversion factor that I found. And I'm going to use highlighter at the beginning to just sort of box around the two pieces of information that I started with. So I started with 12 kilometers, and I knew that it was going 4.2 millimeters per month. So that way I can kind of pop out, here's what I was given, and then here's what I got when I was halfway through, and then here's what I got when I was done. Alright, so that's a good example problem. And I can go ahead and highlight some of the other ones. So now I've added some highlights, and you can see that this page kind of pops out a little bit. We compare it to the previous pages. It's a little bit more fun to look at these notes with the colors added, and it makes it a little bit easier to find the important pieces. So now I've got this blank one here, and I want you guys to come up with your own example problem. And you can make it simple if you'd like, but basically, how many blank in blank? So for example, if you know your height, so I am 5 feet 2 inches, I'm short. How many centimeters is that? So if you do this, use your own height, and if you're 5'2", then use a different one, because I don't want everybody to have the exact same one, and I will be checking. So if I'm 5 feet 2 inches, how many centimeters is that? Well, it's going to be a lot easier if these were the same unit. So I am 2 inches plus 5 feet times the conversion factor to change feet to inches. So how many inches are in a foot? 12. And so we've got 12 inches, 1 foot. So I get rid of feet, and now I've got 2 plus 5 times 12. So I know, hey Google, what is 5 times 12?
The answer is 60.
Nice. So I am 62 inches. Alright. Hey Google, how many centimeters are in 1 inch?
1 inch is equal to 2.54 centimeters. To convert from inches to
Hey Google,
centimeters...
stop. Sometimes that can be pretty useful. I had this memorized, but I'm just showing you guys, use the resources that you've got. So if 1 inch is the same as 2.54 centimeters, I want centimeters to be my new unit, the one that I'm going for. So that means the old unit needs to be on the bottom. So when I write this conversion factor, I'm going to put inches on the bottom so that they will cancel out. So I've got 62 inches multiplied by the conversion factor that has inches on the bottom. So 2.54 centimeters divided by 1 inch. And so this is my math problem, and that would give me the answer, how many centimeters tall I am. Hey Google, what is 62 times 2.54?
The answer is 157.48.
I am 157.48 centimeters tall. So go ahead and do your own problem. Find your height, or maybe find something else. Maybe if you want to calculate your weight in stones instead of pounds, the way the British do, you could do it that way. So I'm going to go ahead and I am 5 feet 2 inches. How many centimeters is that? Have your own practice problem here. So I have finished the unit conversion notes. I've got my conversion factor, what it is and how you use it, and I've got example problems here. And you should have something similar. Thank you for paying attention and listening, and I hope to see you in the next video.